Alrighty, I just wanted to make a quick video that went over what we covered in class today. While this is not actually a section from the unit, you do need to know this stuff to be able to do the next section that we're going to be doing in the unit. So this first part here, we were talking about the rules of exponents. Before we jump into the rules, I just want to make sure that everybody understands what exponents mean. For example, if you had 5 to the 4th in the start thinking part, that just means 5 times itself 4 times. Then if you have x to the 5th, that means x times itself 5 times. So just make sure that you understand the concept of exponents. Now we have these different rules that we're going to be looking at here. If you have x to the 3rd times x to the 4th, those both have the same exact base of x, so they can be combined. And you should remember from your previous class, I think you learned this in 8th grade math, you either add those exponents, subtract them, multiply them, or divide them, or do something with that. So rather than having to memorize this, you can expand x to the 3rd, getting 3x's, x to the 4th is 4x's, and you see that you end up with 7x's. So you ask yourself, what could you possibly be doing with the 3 and the 4 to get 7, and you add them. So the rule is if you have two bases that are like, both x's or both 5's or both whatever the base is, and they both have exponents, you can add the exponents together. So it would be x to the m, x to the n equals, that's supposed to say x to the m plus n. Not just m plus n, it's x to the m plus n. Now the next one, we have x to the 3rd to the 4th. Now you're either going to add, subtract, multiply, or divide those exponents, and if you expand this to be x to the 3rd, x to the 3rd, x to the 3rd, x to the 3rd, you end up having, when you add up all the 3's, you get 12 of them. So you ask yourself, what could I possibly be doing with the 3 and the 4? You're multiplying them together. So in this case, you have x to the m to the n equals x to the m times n. The next one is what happens if you have like bases, but they're on in the numerator and in the denominator. So if you had x to the 5th and x to the 2nd, what do you do here? Well, if we expand it, we have 5x's and 2x's down below, and we cancel things out, you find out that you have 3x's left in the numerator. So that would be x to the 3rd. Well, what could you possibly be doing with the 5 and the 2? You're subtracting them. So you get, as you see here, x to the m over x to the n equals x to the m minus n. You're going to subtract them. A different way you could also do this is just say, like I did before, there's 5x's up above, there's 2x's below. When I cancel, how many will be left and where? This is super handy if those were flipped, if it was x squared over x to the 5th, because you don't really want to end up with a negative exponent that then you're going to have to deal with. You could just say, I have a certain number of x's down below, and that is the easier way to do this. Now, the next one, several students in class remembered that anything to the 0 power equals 1, but they didn't really remember why that is. So I have these two different reasons here. The first one is if you had x to the 5th over x to the 5th, if you do that subtraction of the exponents, you get x to the 0, and anything over itself just means 1. So that means x to the 0 equals 1. The other one on here, you say x to the 5th over x to the something equals x to the 5th. We know we subtract the exponents, and if nothing's changing, it's 5 minus something equals 5. It's got to be a 0, so that you know that it's going to be x to the 0 down below. And what is the only way that x to the 5th can be divided by something and still get x to the 5th? It has to be divided by 1, which tells you that x to the 0 has to equal 1. The next one here was talking about negative exponents and what we do with it. So I had the little table, and I had 2 to the x, and I put in a 3, so 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2, and 2 to the 0 is 1. So we're there. Those are all positive exponents, though. Then we go over and get to the negative 1 and the negative 2. Well, if you look at a pattern here, how do I get from 8 to 4 and 4 to 2 and 2 to 1? You are going to be dividing by 2 each time. So once we're at 1, how do I get 1 to the right? You divide by 2 again. So that means that 2 to the negative 1st actually equals 1 over 2. And then 2 to the negative 2nd, you divide by 2 again, getting 1 over 4, or 1 over 2 squared. So 2 to the negative 2nd equals 1 over 2 to the 2nd. So the pattern we're seeing here is just that if you have a negative exponent, if you move it down to the denominator, it becomes positive. And likewise, if it is already in the denominator, it's negative, you could just move it to the numerator and then it becomes positive. Okay. Also, the concept of a negative exponent. If you had like 5 to the 3rd, that means multiply by 5 3 times. If you have 5 to the negative 3rd, It means the opposite of that. It means divide by 5 3 times, which is like 1/5, 1/5, 1/5, which explains why you would have it as a positive exponent in the denominator. Now, when you get a crazy problem like this that's got a bunch of stuff going on, you can do this in so many different orders. Me personally, I do not like negative exponents. So rather than combining anything first, I decide just to rewrite it, but only with positive exponents. So I go one piece at a time, and if it has a negative exponent, I move it. So from that first step to the second, all I did was I just moved things that had negative exponents. Then what I did was x to the third to the fourth is x to the 12th. That's the only change I made. Then I went over and started combining things I could combine. And then lastly, when I was looking at this and I saw there were 12 x's up top, 5 down below, that means that you have 7 up top. You have 10 m's up top, 6 m's down below. You end up with 4 m's up top. So that is how I simplified that. No negative exponents, nothing that can still be combined, no zero exponents. Also, you can see that x to the 0 I knew was 1. So I just said 1 times all that stuff is just all that stuff. The students then went over and tried this problem right here. Once again, just get rid of all the negative exponents by moving things. Then we had x to the 4th to the 2nd, became x to the 8th. Then I combined things, and then I tried to figure out how many k's there would be and where, either in the numerator or the denominator, and the same thing with the x's. And you can see how I got those. Now, the second part of our lesson had to do with trying to figure out a single number that you can multiply by to get a certain desired effect. So for example, if I said you had a $50 item and there was a 9% tax, you could say 50 plus 50 times 0.09, but there's actually a way to just multiply by a single number and get the same exact result. So we're trying to figure out a single number that would do the same thing as two things. So this first one was basic. It was just, how do you make something 4 times as big? Well, you just multiply by 4. That's common sense. This is where it gets a little trickier. If I want to find out how to get a number that is 50% bigger, most people would usually think multiply by 0.5. But if you ever multiply by a number smaller than 1, it gets smaller. It doesn't get bigger. So you cannot multiply by 0.5 and think that you're going to get larger. That'll tell you how much you're increasing by. But an easy way of doing this, and you could go over and add that to the original, but the easiest way to do this is 30 times 1 will give you the original 30 that you started with. 30 times 0.5 gives you the increase. And when you combine those things, you can say just multiply by 1.5, and it's the same thing as getting the 100% that you started with and then the extra 50%. The way I explain it is, if I went to Vegas with $1,000 and I came back with $1,000, I did not gain anything and I did not lose anything, but I still have to account for the 100% of my own money I started with. Now the next one is 8% bigger. So you have to have that 1 to get the original number and then multiply by 0.08. And together it says multiply by 1.08. The next one is 200% bigger. You still have to account for the 100%, which gets you your original number, and then multiply by 2 to get the 200%. So you multiply by 3. The next one is a little trickier because in this case, you're trying to get smaller. If you're trying to get 20% smaller, the biggest mistake people make is they try to multiply by 0.2. But multiplying by 0.2 is taking almost everything away. That actually is taking 80% of it away and only leaving 20%. So the way we do this is the 1 means the 100% we would normally have, and then you're taking away the 20%, which leaves you with 80%. So a 20% decrease is actually a 0.8 you're going to multiply by. That means you still have 80%. The next one, 7% decrease, means a 93% you still have, and that's why you multiply by 0.93. And the last one is a 75% decrease, means you still have 25%. So you go over and multiply by 0.25. That is what you still have left. And I had all these questions to ask on the side to ask if your answer is reasonable. For example, when you're taking 75% away, you should be closer to 0 than the original total, which was 18. And when you get to 4.5, that is closer to 0 than 18. So you can ask yourself if your answers are reasonable or not. Now, your homework here, when you are trying to get twice as big, you multiply by 2. That's kind of common sense. Once again, 30% bigger is you have to account for having the 50 you originally started with. So that is going to be multiplied by 1.3, not just by 0.3. The 1.3, the 1 gives you the original 50, the 0.3 gives you the increase. On the next one, we're not going to multiply by for 4%, not 0.4, not even 0.0435, even though that does mean 4.35%. We're going to multiply by 1.0435. And when you do that, that is going to take care of the 1, which is multiplying by to get the 10 that you started with. And then when you multiply by the 0.0435, that is the increase. Now on the next one, you're going 40% smaller. And remember, the question is always, how much do I have left? If I go down by 40%, the decimal that I put in here should be how much I have left. I have 60% left. And that's why you have times 0.6. The next one, if I have 90% going away, then I only have 10% left. And that's why I go over and say multiply by 0.1. All right, on the bottom here, we have the basic rules of making sure you know when to add the exponents like the first one, when you multiply them like the second, when you subtract them like the third, when you have to move it and make it a positive exponent like D, knowing that anything to the 0 power equals 1. And then we had those last problems, which were challenging. Like I said, the way, and I always make mistakes. For all I know, I made a mistake on one of these, and the kids will catch it tomorrow when we go over it, because there's so many little places to mess up. But the way that I have found that I mess up the least is just getting rid of all negative exponents first. That m to the -8th, it's a -8, so I should drop it down to make it positive. Down below, you have the m to the -4th. I'm just going to bring it up, and that makes it positive. So I just got rid of all negative exponents. Then I had m to the 3rd to the 2nd, which I made m to the 6th. Then I started combining things in the numerator and the denominator. And then I went over and started canceling things out, of saying there's 10 m's up top, 8 m's down below. In the end, I'll end up with 2 up top. So that's the best way that I've found to do it. The next one, same deal. I'm going to go over and get rid of any negative exponents. You can see the first step has the same thing, just no negative exponents. I then had the x to the 2nd to the 5th, which got me the x to the 10th. Then I combined anything I could combine. And then I was asking myself, how many x's am I going to be left with and where? How many k's am I going to be left with and where? And you can see my final answer there. Okay, as I said, this is not a lesson specifically from this unit, but you do need to know this stuff to be able to do the next section, which is going to be making equations for exponential growth. All right, thanks for watching.